This video will cover notes 10D, solving radical equations. So we've already actually solved some basic radical equations with the Pythagorean theorem, but now we're going to look at a little bit more different types of radical equations. So before we dive into radical equations, just kind of a brief overview of what it means to solve an equation. So for instance, if we have x squared or x plus 2 equals 6, then how would we solve for x in that case? Well, to get x by itself, we want to get x by itself, we would have to subtract this 2 that's sitting here from both sides, okay? And then you would get x equals 4. So you want to do the opposite of what you see. So you see addition, so you would subtract in order to undo that addition. All right, and then for the next one, 5x equals 20, what's happening with x? Well, 5 is multiplying with x, so to undo multiplication, you would divide. All right, so solving an equation involves looking for opposite operations: addition, subtraction, division, multiplication. So squaring something and taking the square root of something are opposite operations. So if I have x squared equals 4 and I want to get x by itself, well, how do you undo a squared? Well, you take the square root of both sides. And so the square and a square root, just like my 2 and minus 2 canceled, the square and the square root kind of cancel each other out, leaving you with x being just equal to 2. So if you see a square, then the opposite is to take the square root. And then for the last example, we have x squared, and so to undo an x squared, then we would have to square that whole thing. Sorry, that should have been parentheses. So we square both sides, and then you would get 16. So the opposite of a square root is to square both sides. Okay, so those are the opposite operations. So let's look at some examples where we have a square root and we need to square both sides. So for example 1, it says solve and then check. And actually checking when you have radical equations is extremely, extremely important. In fact, I'm going to require you to check your answer, and I'm going to show you why. So if you have the square root of a equals 7, to solve for that, you want to get a by itself. A has a square root, so we want to square both sides in order to get rid of that square root. So then the square root of a squared is just a, and then 7 squared is equal to 49. Okay, now I know this one seems pretty arbitrary to check our solution, but I want you to check. So then if a is equal to 49, if we put 49 in for a, and then check to see if that equals 7, the square root of 49 is 7, so therefore that checks off. Okay, but now for b, this actually is a little different. So if I have the square root of c, we want to get rid of the square root, so we're going to square both sides. So the square root of c squared is c. And then negative 4 squared, remember a negative squared is going to be positive. So negative 4 squared is 16. Now, if you were to check this equation, then you would get the square root of 16 is equal to negative 4. But the square root of 16, when I square something, if there's no negative sign in front of the square root, if I square something, you're getting a positive 4. And positive 4 does not equal negative 4. So that is actually not a solution. So, and actually I can go ahead and show you, if you ever get a square root of something, I'm going to rewrite my equation for part B. You can go ahead and see if I have a square root of c and that just equals a negative number, that's not going to happen, because when you square root something, if the square root has already been taken, then you can only get a positive answer. So this case would actually be no solution. So this is one of those cases where I could actually solve part B and get an answer, c equals 16, but that actually wasn't the correct answer because the square root of 16 is positive 4, not negative 4. So what we call that type of solution is if you solve and you get an answer, but then it doesn't work, that has a word for it that you need to memorize. It's called an extraneous solution. Okay, you can kind of think like an extra solution. It's an extra solution, it's not really a solution. So it's called an extraneous solution. And so extraneous solutions can be created when we square both sides of an equation. Now, when you take the square root of both sides of the equation, that's okay. But if you square both sides of an equation, you can get extraneous solutions. So since we have these extraneous solutions, whenever we solve, and in the past, it's always a good idea to check our solutions, okay? Always. But in the past, I never required you to check your solutions. But now that you have this possibility of having extraneous solutions, it is especially important when you're solving square root equations in order to check your solutions. And not even especially important, but really for this class, and really in all math classes that you're going to see, it's going to be required that you check your solutions, because not always will your solutions be real solutions. Okay, so to solve an equation involving a radical, we already talked about this, you're wanting to isolate the radical itself first. Okay, so just get the radical. If there's anything in front of the radical or adding or subtracting from the radical, you want to get rid of that. So get the radical by itself first. Then, when you have the radical isolated, then you're going to square both sides of the equation and solve. And then after that, you want to check. All right, so let's try example 2. So example 2, that's involving a radical. And again, in order to solve, I want to get that radical by itself first. And actually, in this first example, it's already by itself, because the 5x minus 1, remember that's called the radicand. All of that is under the radical. There's nothing outside of that radical that hasn't been taken care of. So at this point, I'm going to square both sides of the equation. So when I square that 5x minus 1, the square root just goes away. Okay? And then on the other side, we do have 3 squared, which is 9. And so now you solve. So we add 1 to both sides, so we get 5x equals 10. Divide by 5. 10 divided by 5 is 2. Now, do not stop there. Box your answer and move on. Since we took the square of both sides, you are required to check. So what I mean by check is I want you to rewrite your equation and replace that x with your solution. So I'm going to say 5 times my solution is 2 minus 1, and see if that equals 3. So solve that way. Now I'm going to use PEMDAS. So inside the radical, you have 5 times 2, which is 10. 10 minus 1 is 9. And the square root of 9 is 3, which equals 3. Therefore, x equals 2 is, in fact, my solution. Okay, so this one did not have an extraneous solution, but you have to check. All right, so let's try part B. Now, part B, notice that my radical is not isolated. I have this a minus 3, that's my radicand, but this plus 2, I need to get rid of that before I can square both sides. So that's what I'm going to do first. I'm going to subtract 2 from both sides, and that leaves me with the square root of a minus 3 equals 5. Now my radical is isolated, so now I can square both sides. All right, so now that does away with the square root and the squared on the left side, leaving me with just a minus 3, and 5 squared is 25. Now, simply add 3 to both sides, and we get a is equal to 28. Okay, so now we're going to check for that. So to check, we're going to plug in 28 for a and solve. So 28 minus 3 is 25, so we have the square root of 25 plus 2 equals 7. The square root of 25 is 5, and 5 plus 2 does equal 7. So again, another one where we get the correct answer. So a equals 28 is our correct answer. There was no extraneous solutions. Okay. All right, so finally for part C, let's look at this example. I think we are going to have an extraneous solution for part C. Okay, now notice for part C, I have both an x on the left side that does not have a square root, and an x on the right side that is inside of square root. Now, if you look again, we want to isolate the radical, and in this case, the radical is isolated right now. So, since the radical is isolated, we're going to square both sides. It doesn't matter which side the radical is on, left or right, as long as it's isolated. So now when I square both sides, you're going to get x squared equals x plus 20. Now, I'm going to pause here because this equation is a little different than the other two that we've done. The other two that we've done, when we square both sides, so like here, we get a linear equation. That means that the a value has a power of 1. Okay, so all we have to do is add or subtract, multiply or divide, and we get our answer. But in part C, we actually have a quadratic equation. That means we have an x squared involved. Whenever you have a quadratic, you have to solve by either factoring or by the quadratic formula, which we learned, talked about in the last class. So when I have the quadratic formula, or quadratic equation, you have to set equal to 0. Okay, so remember that we had a whole 2 units over that. So what I mean by that, I want the x squared, I want to write this as a quadratic, ax squared plus bx plus c. So what I'm going to do is I'm going to subtract my x and subtract my 20 on both sides, and I will end up getting x squared minus x minus 20 equals 0, because everything will cross out. Okay, so now you have that ax squared plus bx plus c, and now we're going to try to factor. Sometimes it doesn't factor. If it doesn't factor, we use quadratic formula, but this one does factor. So we use the AC method. So a times c would be 1 times negative 20, so that's negative 20. And then factors of 20, and then we want to make negative 1, right? Okay, so that's our b. So what I think of is 4 and 5. And so to make a negative 1, that would be 4 minus 5. Okay, now since a is 1, I can use my shortcut method to go straight into x plus 4. So that would be a positive 4. And then x minus 5 equals 0. Okay? And remember, when that equals 0, x plus 4 equals 0 means that x would equal negative 4, and x minus 5 equals 0 would mean that x equals positive 5. So what this means is I actually have 2 solutions. I have 2 values of x, which would make this equation true. But remember, it might be an extraneous solution. So we're going to check both negative 5, or negative 4, and 5. Okay? So let's check negative 4 first. Okay? So if I plug in negative 4, we get negative 4 equals the square root of negative 4 plus 20. And so you get negative 4 equals 20 minus 4 is 16. So the square root of 16 is positive 4. So you get negative 4 equals, so sorry, I'm running out of space. You get negative 4 equals positive 4, which does not work. So what that means is negative 4 is an extraneous solution. All right, now if you check x equals 5 into my equation, you get 5 equals the square root of 5 plus 25, or sorry, 20, and you can see where this is going. We have 5 plus 20 is 25, therefore 5 equals 5. That does work. So negative 4 is an extraneous solution, so 5 is my only real solution for this problem. Okay, we're just going to try just a couple more and then we're done. So example 3 is a little bit different. So let's look at A. And is the radical isolated? That's the first thing you want to do when you have a radical, is you want to get the radical by itself. For part A, it is. So once the radical is by itself, your step is to square both sides. Now notice what I'm doing. On the left side, we have x minus 4. We have a binomial. We have 2 things that will have to be squared. So we have to put parentheses around that. Now remember, this is not equal to x squared minus 4 squared of 16. Remember, that is never, ever, ever, ever the case when you square a binomial, when you square 2 terms. Okay, when you square those 2 terms at x minus 4, you have to write it as x minus 4 times x minus 4. Now the right side, the square root and the squared cancel each other out, so we get 2x minus 5. Now, on the left side, we have to do the double distribute. Okay, so we get x squared minus 4x minus 4x. Then be careful, the negative times the negative becomes a positive. 4 times 4 is 16. Okay, now remember I told you that if you ever have a squared involved, then you're going to have to factor, and you have to set your equation equal to 0. So first of all, before I do that, I'm going to simplify my left side by combining like terms. So I have x squared minus 8x plus 16 equals 2x minus 5. Now, I need to make this equal to 0, so I'm going to subtract my 2x, and then my negative 5, I'm going to add that. So the 2x will subtract from the negative 8x, and the 5 will add to the 16. All right, so now I have x squared minus 10x plus 21 equals 0. The first thing I would try is to see if it factors. So to see if it factors, I have a times c is 1 times 21, so that's 21. And I want to add or subtract to make negative 10. Now, since it's negative 10, and it's multiplying to get positive 21, that means both my answers are going to be negative, and I think of negative 3 and negative 7. Since a is 1, I can go straight into my factored form. So that would be x minus 3 times x minus 7 equals 0. And then my x values are just going to be the opposites, so 3 and 7. Again, we want to check for extraneous roots, or extraneous solutions. So I'm going to plug 3 and 7 back into my original equation, what was typed in your notes. Okay? So let's check 3. All right, so that would be 3 minus 4 equals the square root of 2 times 3 minus 5. Okay? So we have on the left 3 minus 4 is negative 1. I can go ahead and tell you if you have a negative equaling a square root, that's not going to work. Because what's going to happen is the square root, so 6 minus 5 is 1, the square root is going to have to be positive, which can never equal a negative, so that's not the case. So 3 would be considered an extraneous solution. Not extra, but extraneous, so that's just shorthand. All right, so now we need to check 7. So again, we're going to plug in 7 for x. So we have 7 minus 4 equals the square root of 2 times 7 minus 5. 7 minus 4 is 3 equals square root of 14 minus 5. So 3 equals the square root of 9, and yes, that does check out. So 3 is extraneous, so 7 is my only solution. Okay, our final example, B. So again, we want to isolate the radical. So notice that my radical is this 18 minus 2x. So this plus x on the end, that is not part of the radical, so we need to get rid of that first. So I'm going to subtract x from both sides. So that gives me 5 minus x, because 5 minus x is just 5 minus x, equals the square root of 18 minus 2x. Now the radical is isolated, so I'm going to square both sides. And notice again, I have this binomial, 5 minus x being squared. You cannot just say 5 squared is 25 minus x squared. You have to write it as two binomials, 5 minus x times 5 minus x. And then that would equal the other side. The radical cancels out, so we just have 18 minus 2x. So now we want to double distribute again. So 5 times 5 is 25. 5 times negative x is negative 5x. Negative x, again, times 5 is negative 5x again. And then, careful, negative x times negative x will be a positive. X times x is x squared. Watch out for those negatives. Other side stays the same. Now, remember I want to write this as a quadratic, so that's ax squared plus bx plus c. And remember, to solve a quadratic, we have to equal 0. So I'm going to do a couple of things here. First, on the left side, I'm going to simplify it as well as kind of switch my terms around so that x squared comes first, then the x, then the c. So that x squared, I'm going to write that first. Then my negative 5x and negative 5x make negative 10x. Then finally, the 25, I'm going to write that last. Okay, so notice how I've rewritten that in standard form. Still equal to 18 minus 2x. So now I want to solve. So in order to solve, I'm going to have to subtract my 18 and add my 2x. So the 18 is a number, there's no x with it, so you're going to subtract that from 25. And you're going to add 2x to the negative 10x. All right, so now simplify that and you get x squared, negative 10 plus 2x is negative 8x. And then 25 minus 18 is plus 7, and that equals 0. All right, so then let's factor that. A times c is 7. And the only factors of 7 are 1 and 7. So how does that make negative 8? They both have to be negative. So since a is 1, we can go straight into factored form and say that's x minus 1 times x minus 7 equals 0. So x is equal to 1 and 7. But remember, we have to check. So let's check x equals 1. So again, I'm going to go back to the very beginning, what was typed, and plug in 1 and see if we get an answer. So we have 5 equals the square root of 18 minus 2 times 1, and then plus 1. So we have 5 equals the square root of 18 minus 2 is 16 plus 1, and 16 is 4 plus 1, so that checks out. So 1 works. Now let's check 7. So we have 7 equals the square root of 18 minus 2 times 7 plus 1. So 7 equals the square root of 18 minus 14 plus 1. 18 minus 14 is 4. So we get 7 equals 2 plus 1, which is definitely not true. So what that means is 7 is an extraneous solution. So that means that our only solution is 1. Okay? Sorry that video went over, but that is solving radical equations.